Hello, and we are live again. So this is final revision time, right? So we are again continuing with the same spirit and practicing with the, you know, less than, I guess, 25 days left or so. It's already 2nd of November, right? Okay, so I'm sure that all of you are looking forward to practicing as always. Final revision. So we are again continuing the problems, the questions. In order to well get a sense of all the basics right, and exposing ourselves to again a variety of problems. Okay, so here we go. Let's start something that you have been waiting for, right? So this will again, we'll again keep on meeting regularly, right? Final revision, right? Here we go. Just to remind you about CDC 4, to get the real feeling of the exam, just in time. In case you don't know, so November 16th is the date, right? It will give you the real feeling of going to a center. You'll get your admit card, all the drill of the exam you will go through, right? Just 2 weeks prior to the actual exam. Bookings are ongoing and open until November 12th, right? Hello, Ria. Hello, everyone. Right. I'm excited. I think you also must be. Let's see, right? Let's start. Okay, right. As always, arithmetic is always the pillar of, uh, quant section. So therefore, let's start with that. Percentages. So Amir earns 25% less than Chetan, while Bimal earns 20% more than Amir. Bimal's expenses are the average of that of Amir and Chetan. So expense, income, also savings. Chetan's expenses are 50% more than his savings. Question is finally asking what fraction of his income does Bimal save. So three people and tracking their income, expense, savings, right? Whereby income is always the sum of expense and savings, right? So typically, since just like we normally see in these kind of questions, no monetary values are given, and always therefore the idea is to assume some numbers that should help us, right? The first sentence helps us establish, uh, right, I think the relationship between the incomes, right, earnings, right? So we get some kind of a relationship, right, says that Amir earns 25% less, so 1/4 less. So can I say Amir's income is basically 3/4 of Chetan's income? So if I can say that the ratio of Amir to Chetan in terms of the income is 3:4, right? Amir to Chetan, right? So any percentage comparison gives us the ratio, right? While Bimal earns 20% more than Amir. So Bimal to Amir, the ratio of income is, so 20% is 1/5. So it's 1/5 more. So it is 1 plus 1 by 5 or 6 by 5 times. So the ratio is 6:5. So we can now interconnect these ratios very easily. Amir's value is 3 and 5 in both the ratios. So the common multiple is 15, right? So ratio of incomes for the three persons, A, B, C. If I take Amir's income as 15, then A is to B, 5 is to 6. So 15 is to 18, right? So this is 18. And from the other side, so 3 is to 4. So into 5, 3 into 5, and 4 into 5, 20. So 20, right? So that's, we have combined the ratio. So that's a starting point. And then 15, 18, 20. So we can give it some numbers, right? You can take it as 15, 18, 20 itself, right? Or you can take it as 150, 180, 120, anything is fine, right? So Amir, Bimal, and Chetan. By the way, I hope I have set the agenda right. I guess people are expecting I am going to solve the questions for you. You are expected to solve with me. So I'm expecting you to give me the answer faster than I can solve that, right? The idea is not to look at the discussion and just, right? go through the solution, but to try, right, and get the answer as fast as you can. So I'm looking forward to see your response. Give me your answers in the chat box. That's what this live session is all about. Otherwise, what's the fun? You can always watch the video later on and just go through the solution. That's not the point, right? So therefore, solve with me, right, means get the answer on your own. Okay, I am solving, but you try to solve faster than I can. Okay, so therefore I was saying there is income, there is expense, and there is savings. So in these questions, what I typically do is just make a small table like this and just note the numbers. So I'm taking it as what I'm taking it as anything, right? I mean to say I could have taken 150, 180, 200. I'm just taking 15, 18, 20, right? Okay, so now I guess we have to establish something about saving for Bimal. Bimal's expenses are the average of Chetan and Amir's. So we'll come back to that later on once we have seen what we can do. Chetan's expenses are 50% more than his savings. Okay, there is saying 1 by 2. Let's see. Uh, Chetan's expenses. So 50% more means 1.5 times, or the ratio is 1.5 or 3 by 2. So we have to split 20 over here, the Chetan's income in the ratio of 3:2, right? And expense is more than savings. So 3:2, right? So 20, I guess 12 and 8, right? That is 3:2, right? Whereas Amir's savings are 50% more than his expenses, right? So again, we have to split in the ratio of 3:2, but savings are more this time. So 15, I guess 9 and 6, 3:2. Okay, so we have got this. Now we can say that from this statement that Chetan's expense, Bimal's expenses are the average of that of Amir and Chetan. So we have got these expenses 6 and 12. So their average is simply 9. So out of the income of Bimal, which is 18, he is spending 9 and therefore saving also 9. Yeah, so thank you there, your answer is correct, because he's saving exactly what, half of his income, right? Half is the correct choice, right? So point number 1, ratios help. Ratio can be established from percentage comparison. Point number 1. Point number 2, with so much information, make a neat table as I have done over here to efficiently manage your values, right? That helps. Okay, because this is the crunch time and we are here not just to know how to solve, but how to solve efficiently, right? Okay, so in that spirit, here we go. Next one. Okay, mixtures and alligation. Let's see. Bottle A is filled with a solution of milk and water, 4:1 ratio. Bottle B is filled with a solution of milk and honey, 9:1 ratio. Three things are involved, not two things, because the first solution is milk water. The second is not again milk water, but something else, milk and honey. Capacity of bottle A is thrice of bottle B. The contents are emptied in a large container. What is the ratio of milk to honey? So the point is, you have been given these two ratios, and you have to interlink them from the further condition of this volume or capacity condition, right? So in A, we have milk and water, and that is 4:1. So if I take 4 and 1, then the total volume is right now 5 units. For B, it's milk and honey, and that's in the ratio of 9:1. So that is a total volume of 10 units, right? Now, what capacity of bottle A is actually thrice of bottle B. So actually, if this is taken as 10 units, then this should be actually 30. So we can equate these. I mean, we can correlate these two ratios, 4:1 and 9:1, right, by multiplying 5 with 6 to, so that the volume 30 is matching with what we want. So we need to multiply this whole with a factor of 6, and we can say that the total volume is 30, and therefore 6 into 4, this is 24 units and 6 units. So therefore, right? Again, we can therefore say that, okay, we have got 24, 6, 9, 1. Now these numbers are interlinked, such that we can say that for every 24 units of milk in, bottle A, there are 9 units of milk in bottle B. And therefore, if we are now mixing them, then the ratio of milk to honey is being asked. So the total of milk is 24 plus 9, which is 33 units, whereas your honey is simply that 1 unit over there. So yes, the ratio is what? 33 is to 1. Right? Thank you, Ria. Thank you, Daria. Good that you got it. And you got it faster than I solved. Very good. Right. So the idea is keep it simple, right? I think that's the mantra, right? The the easier you can keep it to, the easy way out is to just directly work with numbers, right? As far as possible, right? So this is how you can interlink the ratios by directly justifying the totals, right? Perfect. And you know it. Next one. Okay, so let me give you just a few seconds to start trying this, and then I'll start. I'm giving you a head start, time and distance. Let me run you. Let me set you a head start. Good to see a lot of people in the session participating. Very good. Right, I'm just drawing till you are doing this. Okay, so right, here we go. A bus has covered 1/8 of the total distance from city A to city B when a car also starts from city A. It catches the bus in an hour and takes 3 more hours to reach city B. So as soon as I look at a fraction 1/8, I want to assume a total distance because I see there is no value given for the distance. I can take it as anything, and then let me start to analyze. So I'm taking the distance as a multiple of 8. I'm taking it as, let's say, 80 kilometers. Okay, in on the whole. Uh, and then let's go from there. So bus has covered therefore 10 kilometers, right? 1/8. So this is some point P and Q. Let's say I'm just marking for the sake of clarity. In fact, it is city A and B. Let me say A and B only. This is B, right? So till some point, call it P, which is 10 kilometers. So 10 kilometers is done, and there is a bus over here. Then the car starts. It catches the bus in an hour, right? And it takes 3 more hours to reach city B. So first of all, look at the ratio over here, right? The total distance is 80. The car takes 1 hour to meet with the bus and 3 hours to then further reach. So the total distance of 80 kilometers, right? Uh, when the car starts, it it takes one. It, can I say it takes 4 hours for the whole journey? 1 hour to catch up with the bus and 3 hours further. So very easily we can say that what is the speed of the car over here. So for the car, the total time of the journey is simply 4 hours for 80 kilometers. So the speed, therefore, I think we have found for the car as 80 kilometers divided by 4 hours, which is, so you can understand. I'm just putting some numbers over here for convenience. This 80 kilometer is my assumption, right? So on that assumption, the speed of the car is 20 kilometers per hour. So in 1 hour, it would have obviously covered 20 kilometers. So the meeting point, let's call that M over here, where the bus and the car meet for the first time, is when the car has covered a total of 20 kilometers. So from this point P, the car has, I mean, this distance from P to M should be 10 because this A to M should be 20 kilometers, right? So this is another 10 kilometers. What does that tell me about the bus? So the bus has covered this distance of 10 kilometers in 1 hour, because in that same 1 hour, the car has moved 20 kilometers and gone from A to M, whereas the bus, which was already at P, has moved from P to M. So therefore, I guess we have also got the speed of the car from this analysis, right? So therefore, okay, good. Some people are giving me the answers already. Very good. which is okay. Two people are saying A option. Thank you. Speed of the bus is 10 kilometers per hour, right? Now, therefore, question is further asking if the car immediately turns back. So now we have to go further. The next, so from point M, obviously car will first reach point B, city B, in 3 hours. So after 3 hours, where will be the bus? Somewhere it will be. It would have covered another 30 kilometers, because in 3 hours, right? So this is the remaining of 60 kilometers, and obviously the bus would have covered 30 kilometers, and the car would have reached there. So the bus would be here, and the car would be now here, and this is another 30 kilometers, right? So from this point onwards, the question is asking if the car immediately now turns back towards city A, in how many more minutes will it meet the bus again? So at this point of time, car is coming here, bus is coming here, relative speed will apply. So the further time taken to meet, right, is the distance to be covered of 30 kilometers upon the sum of the speeds of the two objects, 20 and 10, 30, because they are moving towards each other. So at 30 kilometers per hour, they will meet in another 1 hour. So yes, thank you. Again, Riyadh here. Yes, correct. Answer is 60. Perfect. So quite manageable. Again, you saw that, like, the way we did in the previous questions also with ratios, here also with time and distance, when distance was not given, assuming a number typically makes life easy. Thank you. Good. Right. Moving on. Here we go. Again, let me give you a minute. You made good use of the head start with the last question to give me the answer. Let me give you a minute again. Shubham, let me repeat this very quickly. So there were multiple, stages in this problem. First, at point P, the bus was there. Then in 1 hour, the the car caught up with the bus. Since it takes 3 hours more, so we understand it is taking total for 4 hours for the journey. So its speed is, we took 80 kilometers, so its speed came to be 20, and in 1 hour it must have covered 20. So at point M, where the car met the bus, both had covered 20 kilometers. Now in the next 3 hours, car will reach point B, city B, and the bus from point M will come to this point over here, 30 kilometers further in that 3 hour span, because its speed is 10. So at this point, bus is moving here towards the city B, and car is coming back, having reached city B. It turns back. So they are now coming towards each other, right? They are separated by 30 kilometers. Their speeds are 10 and 20. So what time they will further take to meet each other? That is what is asked. 30 kilometers per hour is the relative speed. 30 kilometers is the distance. They will take 1 hour. As simple as that, right? As I said, assuming the distance makes life easy, right? Right. Thank you. Right. Keep on resolving your doubts. That is why we are here. Okay. So, right, let's start with this one also. Okay. So, having read the question, you must have understood the question is basically talking of children, which are boys and girls, and unmarried women and bachelors, right? So, there are four categories of people over here. I think the objective is, to get the ratio of the number of persons. So, there will be a girl child, there will be children who are girls, there will be children who are boys. So these two are taken together, the children. And then we have the unmarried women, I'm just writing women, and the bachelors, right? The number of unmarried women equals the total number of children, so these two will add up to this. Okay, now you can see that the number is given over here as 40,000, right? So first, the idea is, let's work on the conditions to establish the relationship or ratios, and then we'll get there, right? Again, Dhare has taken advantage and given the answer. Thank you, Dhare. We'll just check. Right. So for every girl child in the town, there are 3 bachelors. So it means if there is one girl, then there are 3 bachelors. So this ratio is 1:3. Okay. I think the most critical statement is this one. If each unmarried woman got married to a bachelor, then 1 in every 9 men shall remain unmarried. What is the meaning of this? So this is the most critical statement, and a little indirect way, of establishing, I think, the ratio between these two uh, categories, right? So imagine 1 in every 9 men shall remain unmarried, which means that if there are 9 men, so 8 of them are getting married. So therefore, there are 8 women, isn't it? And that ninth man is the person who unfortunately does not get married, or fortunately, as you want to say that. Right. So therefore, I think you understand that the ratio is 8:9 between women and the bachelors, right? The unmarried women and the bachelors. So if there are 8 women, then there are 9 bachelors. 8 unmarried women. Let me also clarify, this is unmarried women and this is bachelors, right? Okay, so from there we can now move backwards, that this ratio of girl child to bachelors was right, 1:3. So therefore, if these are 9 bachelors, then these are 3 girls. And now, since the very first statement, unmarried women equal the total number of children, so 8 equals 3 plus 5. So this is the ratio, 3:5:8:9, that we have got. Hence, therefore, we can use finally this number, that if 40,000 are boys, then how many bachelors are there? So 5 is 40. 5 into 8 is 40. I'm saying in thousands. 5 into 8 is 40,000. So ratio, establishing the ratio, keeping the ratio same, this should be 9 into 8, 72,000. Right? Thank you, Dhere. Right? 72,000. Right. So no variables again. Directly making use of the statements to establish the ratio. Keep on linking them one after the other. That is how you master ratios. Right? No variables. Okay, so therefore we are repeatedly, I think, coming across a similar approach, and that is how you can, increase your attempts and increase your efficiency, right? Let's see. Finally, something on geometry. Here we go. Okay, so this is a little bit of a intriguing one. You need to be aware on this equation and its graph. If you don't know, let's learn this. What's the area of the region in square units bounded by these graphs? You can see they all are using modulus. So therefore, what we have is uh, basically the graph of, let me generalize this, mod x by a plus mod y by b equals 1. This is a standard graph. All of you should know this. Is a rhombus centered at the origin and passing through basically a comma 0 minus a comma 0 0 comma b and 0 comma minus b. So that is the standard graph. Mod x by a plus mod y by b equals 1. So these are these equations which we have to then consider, and then we have to find the area. So basically when he says less than equal to, so basically he's talking of the inside region. So we have to plot two such graphs and then find their area. So the first thing to understand is that these graphs are very symmetric with respect to the x and the y axis, right? So clearly you can understand that whatever is the area in the first quadrant will be replicated in all the other 3 quadrants. So the total area is clearly going to be 4 times of the area obtained in the first quadrant. So with that being the basic concept, let us now sketch the curve for the given equations, right? So I'm just focusing on the first quadrant only because I'll just replicate that 4 times, right? So now, so the first one is basically mod x by, this will be mod x by 10 plus mod y by 15 is less than equal to of 1. And the other one will be, mod x This is the first graph, and the second one mod x. So dividing by 30, mod x by 15 plus mod y by 10 less than equal to 1, right? So the intercepts are just swapped around. So just carefully plotting this for the first one, it will be like this, whereby this is 10 comma 0 and that is 0 comma 15. And for the other one, it would be with the 10 on the y-axis and 15 on the x-axis, like this, right? 15 and 10 here. So therefore, you can understand that now this area is basically what I'm interested in, right? This area, right? So this area looks a bit complicated at the first glance because it's a collateral, right? And you can easily understand that the two sides are 10 and 10 each, but finding these sides might be a bit tedious. So the point is, to find the area for quadrilateral, the mantra is always, if you can split it into triangles and get the areas of triangles, that's easiest. And yes, that is very obvious. If you can just join this, which is join the center to this intersection point, and if you can somehow find this intersection point, I guess, then your job is very well done, right? So, and yeah, that is very easy, because so in the first quadrant, these equations are nothing but 3x plus 2y equals 30 and 3y plus 2x equals 30. So very clearly, we can solve these equations very easily and get the point of intersection. So since 3x plus 2y equals 3y plus 2x, so obviously x equals y, and therefore it means that 3x plus 2x or 5x is 30 or x is 6. So therefore, that intersection point is also very easily resolved as 6 comma 6. So therefore, the area of this triangle, the twice of that will be the area of this quadrilateral, right? Because obviously the figure is very symmetric, right? With the same dimensions, 10 on this side, 10 on that side, right? These two triangles are obviously congruent, right? No doubt about that. So the area in the first quadrant is twice of the area of this triangle, and for this triangle, the base is 10 and the height is the obviously this y value, which is 6. The height is 6, right? So with base of 10 and height of 6, area of the triangle is half into 10 into 6. So twice of that becomes 60. And the total area, as we understand, is going to be 4 times of that. So your answer is that the area in square quadrants is 240, right? So first of all, you should be knowing this graph, and this was an application of that, right? A lot of questions have come in recent years on finding the areas. So you need to master all the graphs, and this is one of the graphs which might come up, right? Typically, modulus based equations are thrown across, and you need to plot the corresponding boundary of the graphs and find the area. Perfect. Okay, so I think this is something that we learned something new, right? Let's move on. Next one. Here we go. So now we are deep into algebra functions. Okay, so let's learn. A function y equals fn, which is defined for all natural numbers n, satisfies the relation fn into fn plus 3 plus 1 is 0. So a functional equation is given which links the value of the function 3 terms down the line, right? If you know fn, then you can get f of n plus 3 terms down the line, right? Then you're given 3 values of the function, right? f1, f2, f3 values are given, and then you're asked to find the value of this summation of the values of function from 101 up to 700, which are 600 terms, right? So this function is not a continuous function, remember. It's a discretely defined function. It is only defined for natural numbers. So f of 1.5 does not exist. F of -1 also does not exist, right? Only natural numbers. So in these kind of questions, typically what happens is there is some kind of a pattern. But this is actually more of a question It's an algebra question on functions, and also some kind of a series based logic must be there, some kind of sequence must be there. Otherwise you cannot manually just keep on finding, each of these 600 values. Obviously it is therefore at its core a question of sequence. The point is, find the values of the function. Means f1, f2, f3, start finding what is f4, 5, 6, 7, 8. You will see a pattern emerging, right? Don't be afraid, don't be shy of doing that. You will find a pattern. There is no two ways about that. Once you find that pattern, the question is not too much of a hassle. It's just that when we look at the algebra variables, our mind gets bogged down. So don't let that happen to you, right? So I'm saying, with f1, f2, f3 defined, what is f4? From this, so basically from this relation, uh you know this relation tells me that f of n plus 3 is minus 1 over f of n, is basically what this equation is. F of n plus 3, f of n into f of n plus 3 equals minus 1. So therefore this is what we have. So therefore start finding the values, right? See the pattern. So what is f of 4? Minus 1 by f1 means minus 1 by 2. Then what is f of 5? Minus 1 by f2, which is minus 1 by 4. What is f of 6? Minus 1 by f3, which is minus 1 by 5. Then what will be f of 7? F of 7 then will be minus 1 by f of 4. And f of 4 is minus half. So minus 1 over minus half is back to your f of 1, 2. F7 is eventually the same as f1. So therefore you have got your pattern. The way in which the first 6 terms have come across, that will keep on repeating in a loop infinitely. So this function basically has only 6 unique values, and those 6 unique values in a bunch then keep on repeating in the same loop again and again infinitely, right? F7 is f1, likewise f of 8 will be f of 2, and f of 9 will be f of 3 in the identical manner, right? F of 8 will be minus 1 by f of 5, and with f of 5 being minus 1 by 4, so again it is the same as minus 1 by minus 4, which is back to 4, and so on, right? So therefore these are 600 terms, which is basically 100 times 6 terms, and the sum of 6 terms is nothing but the sum of these 6 numbers, right? So therefore the answer is 100 times the sum of the values of the function for the first 6 times, right? Because wherever you start from, wherever you pick, whether it is starting from f1 or starting from 101, your loop is repeating infinitely, right? So that 6 values will keep on repeating, right? So 100 times what? So 2 plus 4 plus 5, and then minus 1 by 2, minus 1 by 4, minus 1 by 5. So just do this and your answer is there. So 2 plus 4, 6 plus 5, 11. So that's 1100. And then just subtract the remaining. 100 by 250, 100 by 4, 25, 100 by 5, 20. That's 50, 25, 75, and 20, 95. So yeah, I'm getting my answer as what? 1005. 1100 minus 95. Right. So therefore, some questions in algebra we have seen recently, right? This question is on that kind of a pattern where you're given a kind of a functional equation that establishes, a recursive relation on the values of the function, and then you have to find the pattern and then get the values, right? That's what it is about. All right. So now something I think we are taking away, right, as a learning to apply. Okay, let's see what we have for the next one. This was a little bit heavy duty question, but I'm sure the next one you would want to try. Numbers. Don't forget, numbers questions have come directly in the recent years. So let's see, how do you make sense of this one? Giving you a minute to let your thinking process start. right? I hope you're thinking on this one. Right. So I brought a very new question, right? Because new is the mantra, right? Exposure to new things is always good, right? Because out of 22 questions, I could expect, that cat would throw some surprises, maybe 3-4 questions or so. Let's see. So your fundamentals of factors are, I mean, that concept, clarity on concept of factors is obviously being tested in a very different way. For how many 3-digit numbers, right? The number obtained by taking the product of all its digits has exactly 4 factors, right? Good to see your debate ongoing about this. Gaurav, Shubham, let me clarify, right? Let's understand. So see, we know that the number of factors of any number is given by taking the successor of the power of each prime factor and multiplying that out, which means if a number in its prime factorized form n is written as, let's say, p1 power x1 into p2 power x2 into p3 power x3 and so on, where p1 p2 p3 are primes and x1 x2 x3 are the factors, are the respective powers, then the total number of factors of the number is given by x1 plus 1 into x2 plus 1 into x3 plus 1 and so on. As many primes you have, as many times you will, as many terms you will need, right? If there are 7 primes, then you will go on until x7 plus 1, right? So this question is about the reverse logic. If you know the number, you can find the factors. If you know the factors, then what you can do? So you can see that the number of factors depends only on the powers of the prime and not the value of the prime, right? So can I say I can get the skeleton structure of the number in its prime factorized form, which means that how many primes could be there and what could be their respective powers. I will not know the values of the primes, but I will know the structure. Like, for example, 4 factors. So 4 here is x1 plus 1 into x2 plus 1 and so on. So 4 is at the best the product of two numbers only, 2 into 2, or 4 can also be thought as simply 4. So if 4 is thought in the way that there is only one prime such that n is nothing but p power x and there is no other prime, so basically the value of x plus 1 is 4, because there is, if there is only one prime, then the number of factors will again follow the same logic and it will be x plus 1. So basically x is 3. So basically you understand that the number is like the perfect cube of a prime number p cube, where p is prime. It can't be 6 cube to 16. It can only be 2 cube, 3 cube, 5 cube, 7 cube, and so on. Right. So that is one such number. I mean, as I said, structure of the number. So I'm not yet attacking the question. I'm just understanding. If I know 4 factors, what do I know? One possibility is number is the of the form p cube. Or if I think of 4 as being 2 into 2, such that now the number has 2 prime factors, p1 power x1 into p2 power x2. So x1 plus 1 is 2 and x2 plus 1 is 2. So x1 is 1 and x2 is 1, right? So the number is of the form p1 into p2, where p1 and p2 are primes. Now the question starts from here. This is a starting point for the question. Now what's the question asking? How many 3-digit numbers are there in which the number obtained by taking the product of its digits has 4 factors? Okay, so can I just erase all this? I hope this is understood, that we have two things, either n is p cube or n is p1 into p2, right? Let me make some space over here now. Right? So we have just concluded so far that either my number is of the form, it is p cube or it is p1 into p2. So let me start with p cube. So if I take the number n to be of the form a, b, c, then a into b into c is like p cube. P could be 2, 3, 5, 7. So start making the cases. What if a into b into c is 2 cube 8? Then what could be the possibilities? 8 is the product of 3 digits. It could be 118 kind of number with all its arrangements, because now it becomes a counting question for how many numbers. So 118 can be obviously arranged in 3 ways. Or it could be like 124. 1 into 2 into 4 is 8, and then it will have 6 arrangements, 3 factorial, right? With 118 only 3 arrangements because 1 and 1 is repeating, right? So 8 can come in 3 ways. But with 124, the usual 3 objects, 3 factorial arrangements, 6 ways. We can also have 222. That is also possible. That is one such number, right? Uh, so that's what happens if I take P as 2. Now, this is now becomes a proper counting question, right? And you have to exhaustively count. Let's see. Right, good to see your debate ongoing about this, right? So this was P equal to 2. Now P equal to 3. So 3 cube, right? 27 should be the product of the digits. So it could be like what? I can't do 1127. With 2 cube, I could do 118, but here I can't do 1127. But I can start with 139. So that will have 6 arrangements, 3 distinct digits, 139. Then I can obviously have my 333, right? And that is only one such number. Perfect. Okay, so I don't think so anything else, right? P equal to 5. Now I can't do anything except 555 because it's right 5 cube. So you can't even do 1525, right? So you have only one possibility, 555, which is one number. So I'm circling the number of numbers every time. Finally, I think this is the last one with 7 because after 7 the prime is 11. We can't take 11 cube as a product of the digits. Again, only one number, 777, right? So that is another one number. So in total 3 and 6, 9 and 1, 10. And this is 7, 17, 18, 19. So far, we have a total of 19 numbers from this P cube kind of possibility. Now n is P1 into P2. Now here we can do the counting little quickly because whenever we have P1, P2, right, we can, I mean, unless we can combine P1 and P2 and make a single digit P1 into P2, we can only do one P1, P2. So first let's do the counting of all such numbers in which P1 and P2 are distinct digits and kept as one P1, P2. So they can obviously be arranged in 6 ways, each of them, because these will be 3 distinct digits. And P1, P2 will be selected from 2, 3, 5, 7. So selection of 2 primes out of 4 primes can be done in 4C2 ways, 4C2 or 6 ways to select the 2 primes, and then 6 ways to then arrange them. So overall 6 into 6, 36 such numbers will be there. For example, if I have 2 and 3, then 1, 2, 3 can be arranged in 6 ways. If I have 2, 5, then 1, 2, 5 can be arranged in 6 ways. So 6 ways to select the 2 primes and then 6 ways to arrange them. But is there any possibility over here that P1 into P2 can be taken as a single digit? Yes. 2 into 3, 6. And no other possibility. 2 into 5 will be 10, not a digit. So the only exception is when you take 6 as the single digit. So 1, 2, 6. And that also has, sorry, my bad, 116, sorry. And that will have 3 arrangements, right? 116, and that will have 3 arrangements. So 36 and 3, 39 numbers here. So your answer is 39 and 19, 58. A very intriguing question, sets a lot of concepts in place about numbers and particularly factor logic, right? Factors based questions also have come in the recent past. So I think my agenda was to clarify a lot of concepts on factors. If you know the number of factors, you can backtrack the structure of the number in its prime factorized from how many primes and what are the respective powers. So then we had to work and on that further, and then it became basically a PNC problem, right? Counting question, right? Okay, good. Good to see you getting involved in this one. Next one. Let me give you again um, a moment to think on this one. Trying to draw a circle as best I can. Oh, I think I did a fair job. Right. Waiting for your answers. Let me give you a minute to share your answers on thoughts on this. Okay. Gaurav is saying 1/4. Anybody else? Well, please share your answers. So here is what it is. See, 2 points are randomly placed, right? What is the probability that chord AB is longer than the radius of the circle? So the choice of point A is arbitrary, right? As far as finding the probability is concerned, you can select the point A anywhere. Relative to point A, where you select the point B, that makes the, you know, I mean, that brings in the condition whether or not the chord is going to be longer than the radius or not. So with point A fixed arbitrarily anywhere on the circle, with the whole circumference open, until what range can the point B go such that the chord A, obviously the point B, as it is, very close to point A, as the point B is taken very close to point A, the chord length will be quite small, and we can reach until a limit where the chord length is exactly equal to the radius. Beyond that point, the favorable range will start. So the unfavorable range is first what we'll find, right? And on either side, so when the chord is exactly equal to the radius, so something, let's say something around here, and this chord exactly equals the radius r. So obviously, what is the angle made at the center by this chord? Obviously, these two radial lines will be also each equal to r, and this will be obviously an equilateral triangle, r, 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 and therefore this angle will be 60 degree. So can I say this arc AB has basically traced 1/6 part of the circle circumference, with 60 degree being the angle. So this is the unfavorable range, and there is an exact identical range on the other side also. A point, this is let's say B1, this is let's say B2, and again the same thing, that this chord AB equal to R, and this angle being 60 degree, this being 1/6. So therefore this 1/6 and 1/6, this total 1/3 of the circumference is the unfavorable region. So the remaining 2/3 of the range of the circle, right, is the whole available region to place the point B, and then the chord length will be more than the radius of the circle. Right, Gaurav? Right, everyone? Okay, so as I promised, I have brought you the new elements, as well as I have the the concepts which have been tried and tested and have been asked again and again. Both of them we have seen. So good to see your involvement. I am sure that you're all working towards the goal, right? So thank you, and we'll see you once again. And in that spirit, in case if you need help from us, then CAT has its module Power 30, 15 sectional tests, 15 sessions, 15 CTC marks, 315 topic tests, right? Something that you can look out for and check it out over here, right? This is the scanner. Okay, so with the promise to see you again in the same spirit, and uh, you know to learn again, right? We'll see you quite soon. So keep checking our sessions regularly. Thank you so much. I'll see you again, right? Leave your suggestions in the comment box if you want to. I can bring in any specific topics if you want, right? I'd be happy to help as much as possible. Thank you, people. See you.